Hello and welcome to this video on simplifying variable expressions. If you're here, you're most likely a student in my Algebra 2 honors class who's trying to remediate this skill after the summer packet test that we had in the beginning of the year. Um, what I noticed, and I'll try and design this video to speak directly to what I noticed, was that everybody had kind of little pieces, but there were definitely little holes and multiple areas. Okay, so I try to respond specifically to what I saw on the test, not specifically how I would teach the topic, but more so to try and fill in the holes. Okay, so for this topic, success is going to depend on integrating three particular skills: distribution, distributive property, subtracting a quantity, which is very much like the distributive property, and collecting and identifying like terms. So I'm going to try and hit all three of those, and maybe it'll be an opportunity for you guys to fill in some little holes here and there, particular to your situation. Okay, for distribution, one of the things I was saying was a lot of sign mistakes, okay? First off, let's realize that this first problem here is read 2 times the quantity b minus 6, which means we're going to multiply 2 times b and 2 times negative 6. It's one of the things I think can help improve your clerical accuracy is trying to include the sign. Don't bring the negative down while you're saying, oh, it's a minus, and then do 2 times 6. Really just each time you do a multiplication, think of the number as positive or negative, and whatever the result is, make that the sign you bring down. So for instance, 2 times b is 2b. Notice I don't bring the negative down per se. I do 2 times negative 6, which is negative 12, and I kind of express that as minus 12 in the next line. Okay? Similarly here, I'm going to do negative 2 times the quantity of 5 minus 6c plus 7d. Okay? So as I set that up, again, let's try to focus on writing a little particular way, a little bit better here. I think it's going to be a help. So negative 2 times 5 is negative 10. And I have negative 2 times negative 6c, which gives me plus 12c. Okay? And then we have negative 2 times 7d, which is going to give me negative 14d, which I express as minus 14d. Okay, I notice there's no like terms here to combine, so that's pretty much done. If you get into problems where there are fractions such as 1/2 times 2/5 x minus 3/7, you're going to have to rely on your fractions ability, but don't be afraid to grab your calculator if you have to. Okay, so that type of problem shouldn't be beyond your ability to answer. It might take some button work, might take some reviewing of what happened in 4th and 5th grade for your fraction work. Okay, so here we have subtracting a quantity. Okay, so we have a minus the quantity b plus c. Okay, in this first example. Now, one of the things that you guys have been taught, okay, most likely, I'll clone this problem and show you. I'm going to do it both ways here. Both are get you the right answer. I think one's better than the other, but I'll leave it to preference. Okay, so one of the things you guys have been taught is to sit there and put in a 1 where the negative sign is, and then multiply. This will get you the right answer, especially if you mastered the skill in the previous slide. Bring down the a. Negative 1 times b is negative b, which I express as minus b. Negative 1 times c is negative c, which I express as minus c. Okay, I really don't like that. Okay, it gets it right, but I think it subverts your ability to read this well. You're doing multiplication, but the problem didn't say multiplication if you read it. Okay, it said a minus the quantity b plus c. Okay, so I mean, I think it's just only going to make you a better reader if you could start to see this as a minus the quantity b plus c means minus all the terms that are in the quantity. So we're going to subtract b, and then we're going to subtract c, getting the same answer. Okay, you can put the 1 in if you want. You get the same answer. But again, I don't think you're doing the problem as it says. I think you're kind of doing it in a way that's a little different, just happens to get you the same answer. Okay, so maybe we're splitting hairs. So in the end, you got to get it right. You cannot be making sign mistakes here. So similarly here, we have x minus the quantity y minus z. So I'll bring down the x. So we're going to subtract everything in the quantity here, which is subtract the y, which is this minus y, and subtract the negative z, which in fact is going to give us plus z. Okay, and if I were to put in my 1, and distribute, well, I'd pull down my x. You get negative 1 times y is negative y, and negative 1 times negative z is positive z. Okay? So that's just really a lesson in getting your signs accurate here in both these examples, 1 and 2. Okay? So then we've got collecting like terms. Okay, so let's just take a look at what like terms are for a second. Okay? Like terms are, well, let's say what a term is. The terms are math expressions separated by add or subtract. Okay? So if you notice here, we have in this first problem 1, 2, 3, 4, 5, 6 terms. Okay? Now, like terms are where you have the exact same variable base combinations, identical right down to the exponent. Okay? So obviously x and y are not alike because it's so obvious. We tend to think of this as apples and oranges. Okay, very obvious. When I get over to this example here, though, it'll bring up some question. Here we've got x and x squared. Okay, but let me stick on this first example here. Okay, where it says x plus y plus 2 minus x plus 3y plus 8. So the first thing I want you to realize is that x would be like with minus x. And then you've got that positive y would be like with positive 3y. Then you've got this constant term of 2 and another constant term of 8. So we have x minus x. That will cancel. I'll try and keep the colors moving in the same consistent pattern here. Y plus 3y is going to give you 4y. And 2 plus 8 is going to give you 10. And because it's positive, I'll express it as an add in here with addition 4y plus 10. And these are obviously not like terms. This has a variable, this does not. So that's as far as you can go. The answer is 4y plus 10 or 10 plus 4y. Okay, exciting moment here. Example 2. Well, people are just thrown a little bit here and they say, oh my gosh, this is x and x squared. Well, they're both x, right? So they're like terms. They're not. Okay, remember what I said over here where this is very much a apple and an orange? Okay? There's not a lot of convincing to do for the sake that x and y are not like terms. But think of x and x squared as a red apple and a green apple. Okay? And in fact, they're not really the same when you go to organize them. The number x squared is not the same as the number x. Okay? So in this sense, x is a like term only with negative 3x or minus 3x here, and x squared is only going to be a like term for negative 4x squared. So you get x minus 3x is negative 2x, and obviously there's a 1 there. And then I'd get x squared minus 4x is negative 3x squared. These are not like terms again. It's like a red apple and a green apple. A little bit different, and just different enough to be different. Not like enough to be like. Again, one of the things I said earlier is the exponents have to match. That's an exponent of 2. That's an exponent of 1. Okay? So this gets really illustrated down here in example 3 where you have ab squared minus 5a squared b squared plus 2a squared b squared minus 3a squared b. Well, again, you must have the same variable and exponent combination. So this first one is ab squared. So I'm looking for ab squareds, and I don't have any more. So I'll just account for that in the next line. Now you've got negative 5a squared b squared. So now you're looking for terms that have a squared b squared, and this second term matches the third. So you got negative 5a squared b squared plus 2a squared b squared is negative 3a squared b squared. And this last term doesn't match anything to be combined. So it's minus 3a squared b. And that is your final answer, because none of those terms are alike and can be combined beyond that. Okay, so putting it all together here, this is where you really need to be able to shine. You've got examples here with distribution, combining like terms, subtracting quantities here, and I'll move through this decently quickly here. So example 1, you have x plus y times the quantity x plus 4 plus 2xy minus the quantity 3x minus 2xy plus 8. Well, the first thing you want to do is apply the distributive property in all the places you can and subtract your quantities, because that kind of falls under distribution a little bit. Okay, so you've got x plus xy, good to write your variables in alphabetical order, plus 4y. Again, that was from the distributive property. Just writing plus 2xy. Now subtracting this whole quantity is minus 3x minus negative 2xy becomes positive 2xy, and minus 8 becomes minus 8. Now we look for like terms, okay? And I see this x matches this negative 3x, which gives me negative 2x. Now I'm looking for xy terms, xy, 2xy, plus 2xy to the tune of 5xy. And then I've got a term here, again trying to scan from left to right, of 4y, which is being combined with nothing. Similarly, this term of negative 8 is combined with nothing, making my final answer negative 2x plus 5xy plus 4y minus 8. Okay, next example. We've got a plus a times quantity a minus 4 plus 2a minus 3 times quantity a minus 2a squared. Okay, distributive property before collecting like terms, much like it's multiply before add. So we've got a plus a squared minus 4a plus 2a minus 3a plus 6a squared, because I'm doing negative 3 times negative 2a squared. So that would give me positive 6a squared. Okay, so now I'm looking for terms of a. We've got a minus 4a is negative 3a plus 2a is negative a minus 3a is negative 4a. I'll just check that and go a minus 4 is negative 3a plus 2 is negative 1 minus 3a is negative 4a. Then we've got a squared plus 6a squared. It's 7a squared. And I don't believe I have any more terms to combine. And again, a and a squared are not like terms. Green apple, red apple, again, they're close, but not close enough. Okay, so in problem 3, we've got 2x plus 2x times the quantity xy minus 3, minus y times the quantity 5x squared minus 2xy, plus 2xy squared. Again, basic property that's going on here is x times x is x squared. More importantly, you are adding exponents. Just kind of giving a little side time in the margin for that, just to make sure you're down with the fact that I've been doing that, adding exponents when multiplying variables of the same base. Okay, so I'll start with distribution. So I'll bring down my 2x, and then I'm going to go plus 2x squared y minus 6x minus 5x squared y. Again, writing in alphabetical order to keep organization of my variables. Then I've got negative y times negative 2xy becomes positive 2xy squared, and bring down my plus 2xy squared. So now I have 2x minus 6x. In terms of those like terms, negative 4x. Now I'm looking for terms of x squared y, so I've got 2x squared y minus 5x squared y, which is going to give me negative 3x squared y. And then in the end, we're looking for these 2xy squareds to pair up with each other and get 4xy squared. And I kind of engineered this example so you'd sit there and say, oh, they both have x, y, and squared right here. But you notice the squared here is with the x and the squared here is with the y. Again, not exactly like terms. So I hope this filled in some gaps. I went kind of quickly. Sorry it was a little bit long. It says it's 15 minutes on my recorder here. But I think you just need to see a few more examples. Everybody was just kind of vaguely close when we did the pretest. So I hope these are to your advantage. Feel free to watch them again and enjoy.